Hello everyone, NASA launched Artemis 2 program on 1st of April and on 10th of April the mission is going to successfully return to Earth. Artemis 2 program was a planned flyby. It was not an orbiter, meaning it was not supposed to go round and round all around the moon. Plan was to start from the Earth, approach the moon, encircle it half and then recede from the moon, again encircling the Earth, completing a pattern of 8 in space like this. Artemis program has achieved a lot. It has gone to the far side of the moon, has stayed there without direct line of communication from the surface, because just on the opposite side of the moon, the radio waves cannot penetrate through the moon to communicate with any ground station on Earth. It has seen the sunset and the sunrise, it has seen the Earth set and the Earth rise. It has experienced the solar eclipse like we do not do from the surface of the Earth. The astronauts have, because of their positioning behind the moon as well. So they have tested the Orion aircraft, they have tested the shielding capability of the aircrafts because of direct exposure from the solar radiations in these regions. So a lot has been achieved and they're coming back, and they will be succeeded with other missions like Artemis 3 that will plan a successful landing on the surface of the moon after the Apollo mission. And then Artemis 4 is a grand, noble initiative, aspiration to have a permanent lunar post where astronauts will be staying there for months and the supplies will be going from the Earth to the moon. Just like we are maintaining International Space Station, they are planning to maintain a station, a lunar ground station. So it is going to be huge. The only question that needs to be answered further in our discussion for now is why? Why there is so much of interest and why we are having such grand plans for moon. We did that already in 1972 in the Apollo mission when humans landed, and then we lost interest. We went to Mars and Venus and Jupiter and Saturn until Pluto and interstellar missions. But why we are coming back on the moon? That's the question. There has to be obviously strong reasons why so many lunar missions are being planned. So the question is why we are going to go back to the moon, why the moon is seen as a fulcrum for future space missions. One of the reasons I have put here as well, you can see is there's something to do with our planned missions in the Mars that gradually we're going to discuss. Artemis program, first of all, is different. If I have to start to count reasons why we're having lunar missions, India also had Chandrayaan 1 and 2 and 3, finally, very successful mission Chandrayaan 3. Russia and China as a bloc, they are planning International Lunar Research Stations, ILRS, separately than Artemis program of NASA. But Artemis program and the other lunar missions, they are different than Apollo. Apollo mission was a competition with USSR, and the question was who will get there. So it was a competition of going there and putting your flag. Although the flag was waving, but that's a different thing. But it was a competition to have your foot on the moon. Artemis program is much more broad scale and much deeper in its vision. Artemis program is about staying there. As I told you, Artemis 4 will be a planned permanent station, lunar station. Artemis program is not only led by US. Artemis program is very strategic. There are many reasons for the space missions being planned for the moon, the lunar missions. There are scientific reasons, of course, but we'll discuss strategic and economic and technological and astronomical and civilizational reasons, and all these are driving the rationale for the lunar missions. Artemis program is not just a competition between the power blocks, it's a broad-based coalition. And Artemis program is working in the background of Artemis Accord, which NASA and the US government has opened up for collaborating with other countries, not necessarily spacefaring countries. There are very few spacefaring countries, but countries who do not send satellites, who do not do active space explorations, they all are part of the Artemis Accord. And last I checked, 61 countries, and that the number may increase gradually, 61 countries have become the signatory for the Artemis Accord. Artemis Accord is about future lunar governance. It's about technological partnership to bring back the resources from the moon to the Earth. That's one crucial element of it, but overall lunar governance. That could have been done within the Outer Space Treaty under the aegis of UN. Outer Space Treaty of 1967 is under the aegis of UN. And everything could have been worked out within that. But because of rivalry of China and Russia, they want to push them out. And with the rest of the world, they want to get into some kind of agreement. And there are other reasons why they are making it so broad-based, because one reason is that the Outer Space Treaty of 1967 under the aegis of UN doesn't recognize any sovereign claim over anything in the space, anything in the moon. So when you're going to go to the moon and have a permanent station, you're claiming a piece of land on the moon, and in future, of course, you are planning to bring back resources from the surface of the moon to the earth. So whom does the resource belong to, and who can claim all the resources there, in what manner? That will be difficult. If you do it under the aegis of UN, you will not be able to claim it all. So the idea of US is to bring it out of the aegis of UN, but it still require broad-based consensus for other countries to be on board for your claim of the lunar resource. So that's one reason why they are making it broad-based. Another thing is that the mission was very brief in Apollo. They had approximately 3 days of stay, lunar days. But in the Artemis program, the ultimate plan is to have a permanent stay. And there are other reasons why that we will discuss. Why a permanent stay? Apart from resource extraction and the claim and bringing them back on the earth, apart from that, there are good reasons for the permanent stay on the moon. The Apollo mission was on the near side of the moon. There are near side of the moon and the far side of the moon. The far side of the moon is never visible to us. Moon does rotate and revolve, but the time of rotation and revolution time period is approximately the same. So it does rotate, but it rotates so slowly that when it rotates, still the same side is visible to us all the time. So half side of the moon is never visible to us. That we call far side of the moon. And they went to the near side of the moon, and that too in the equatorial region. There are missions that China has sent to the far side of the moon now. But Artemis program is not in the equatorial region, it's in the South Pole. Now there are good reasons why to go to the South Pole. South Pole is very rugged. There are deep craters in the South Pole. But South Pole from scientific point of view is more important, because in these deep craters, there are permanent shadow region where the sunlight never directly enters. So the temperature is very low, around minus 161 degrees Celsius. And they are the preserving museums for the pages of history. And in this low temperature, and with the cover of the water ice, the volatile materials like methane and ammonia and hydrogen sulfide and carbon monoxide and other things which are being preserved, which are the original materials when the moon was formed. Moon was formed around 4.5 billion years ago. And in the equatorial region has the lavas, which are not very old, around 3 billion years old. So they're not the oldest material from the moon. The oldest material on the moon and the original material are supposed to be on the South Pole. That's why, the Artemis program is planned for the lunar South Pole. One of the reasons, scientific reason. I'm going to spell out other reasons, but from the perspective of science, lunar South Pole is much more valuable than the equatorial region. Much more valuable. And it's not just the Artemis program. Every lunar mission, every means every, without any exception, all the lunar missions which are planned for the future are planned for the lunar South Pole, whether that's Chandrayaan 4 of ours, Chandrayaan 5 of ours, or the mission of the Russia and China as a block, Artemis program, any program is planned for the lunar South Pole. Because from the perspective of science, from the perspective of astronomy, the perspective of geology, it's very, very important. We got 382 kg of the sample in the Apollo mission. 382 kg. But this Apollo mission, as you understand, was from the equatorial region. So although we got this amount, but this amount from the perspective of science is not very important. As important it will be to get the sample from the pristine region of the South Pole. The South Pole, it carries deep craters, as I've explained you earlier, where the sunlight do not directly enters. So they have the volatile materials, as I told you, methane, mercury, ammonia, hydrogen sulfide, carbon monoxide, and they are preserved not only by low temperature and absence of direct sunlight that creates a permanently shadowed region, but also the cover of water ice. So a small driller, as we are planning in various missions, also in Chandrayaan 5, which is a joint collaboration with JAXA, the space agency of Japan, and they have the plan. Russia and China have the plan, and the plan is to drill and get the original materials. Scientific perspective, from that point of view, it will be very, very important. So they are deep craters, and they are covered in the deep craters. Imagine it upside down, because we are talking of south pole of the moon. So that is the first reason that I can give you why there's a rush towards moon. Second reason that I can give you is that the moon can act as a stepping stone for Mars. The moon is very near. It's just 3 days away. A mission will take 3 days to reach to the moon. It will take around 6 to 9 months to reach to Mars. So if we are planning for major missions or a human mission for Mars, we cannot be so taking so much of risk without ensuring that the aircrafts and the technologies, they all has been tested. And which would be a better place to test than the moon? Because moon doesn't have atmosphere. Moon surface get all the solar radiations and solar pressures. The moon will provide us a good testing ground for much of the thing that we want to do on Mars, because the atmospheric shielding, which is with the help of the magnetosphere of the Earth, is not present on the moon. Moon doesn't have its magnetic field lines, the global magnetic field lines as the Earth has. So that's why there's no protection, and that's why the pressure of solar radiation, that's why there's no atmosphere. So the things can be tested very well for harsh conditions on the surface of the moon. And that protection is also not there on the Mars. Mars, it is said that in the past had its magnetic field lines, but that global magnetic field lines, because of the slowing down of the Mars, has been gone. So there are local magnetic field lines, but is not as effective as on Earth. So the condition on Mars is also very harsh. It is harsh. And the power supply, well, the incoming solar radiations, if we take that as baseline on the Earth, all of that is present on the moon. So on the moon, especially in the equatorial region, where there is no permanent shadow regions, you can work it out with the solar radiations, and you can take the solar panels for your rovers that can charge the batteries, and batteries can have the rovers move around, or you can take other activities, converting the solar energy into electricity stored in the battery. Much of the satellite work like that. Your other space missions also work like this. Problem is that in the Mars, you cannot have the solar radiations with such efficiency, because there is atmosphere on Mars. That is 1% of density of the Earth, but 95% of that is methane. So it's a thin atmosphere, but within that thin atmosphere, the gas, that's a heavy gas, and to that degree there is some opacity or hindrance, I would say, to the incoming solar radiations. So 40% compared on the surface of the Earth, 40% of that is on the surface of the Mars. So on the Mars, using solar energy is not a very good option. So if we want to have a future mission on Mars, then there are two things. We have to learn to work out with this low incoming solar radiations, or we have to take the nuclear energy. And both the things are planned for the moon missions. NASA has declared both the things. In the permanently shadowed regions, at the top of these ridges, when you come, you get solar radiations, but somewhere below, you get lower solar radiations. So if you want to test something on a very low coming insolations, you can do that in the South Pole. And nevertheless, they have a plan for the nuclear fission reactors, the small reactors, to be planned in the lunar South Pole outpost. So both the preparation for the Mars will be done on the moon. So moon will become the stepping stone for the deeper missions. In the moon, there will be habitats and the life support testing, the closed loop oxygen recycling, waste management, the shielding technology, that all will be tested, because the atmosphere of Mars is also harsh. The surface is also difficult for habitat. So habitat and life support has to be tested first. It will be very reckless to take a mission to the Mars without testing that on the moon. The in-situ resource utilization, this is a big thing and always important for your prelims and for your mains. In-situ resource utilization is quintessential because it is very costly to have a supplies from the surface of the Earth to the moon. Already very costly for International Space Station, which is just around 400 kilometers. but that is manageable. That is manageable. To take supplies to the moon when we are planning for a permanent stay on the moon will be very, very costly. So you have to find ways around it. And the past experiments have done it, like the Perseverance rover of NASA had a MOXIE experiment that would create in situ resources. They have done it, and now they are becoming bold enough to do it on a large scale. So in situ resource utilization, like creating oxygen and hydrogen from water there, using methane as supplies, using carbon dioxide and ammonia there, which are volatile materials in the South Pole. So utilization of these for the survival of humans, that is very important to reduce the dependency of supplies from the earth. But from the moon you can manage still. How would you send supplies to the Mars? It will take 6 to 9 months for one mission to reach there. It will be slow and a very costly thing. So for Mars, in situ resource utilization becomes even more important. And where do you do it first? You do it first on the moon, and then you plan it for the Mars. That's how it has to happen. Radiation data collection, as you're going from the surface of the Earth to the International Space Station, you're protected by the magnetosphere still till there. As you go beyond, the radiations will become more and more and more and more. So how we are doing that in protection of our spacecraft from the exposure, that has to be done and tested first for the lunar missions before we can plan for Mars or deeper missions in the space. And the fission surface power, validating the nuclear systems for low solar environment, that will be important for Mars, but we must be tested before on the surface of the moon. So between the Earth and the Mars, the missions, the mission of the moon becomes very important, and now you can understand and see the significance of it. The third reason, I would say that there are economic reasons, good amount of economic reasons why the missions are being planned. Economic reason, you'll prepare your fuel first of all there, and you have to learn how to do it, the electrolysis on water to develop your own fuel hydrogen and your oxidizer oxygen. That is one thing you will learn in the in situ resource utilization currently planned. Another thing is that on the surface of the moon, there are many resources. One of the resources is helium-3. Helium-3 is theorized fuel for future fusion reactors, and the testing of the fusion reactors are currently going on. And if we can manage, by the time we complete the testing and suppose it becomes a reality on Earth, the fusion reactors, almost by the same time we can able to bring helium from the moon, that will be a big bonanza. The problem of electricity generation on Earth will be solved when the two things will become reality. Helium-3 from the moon comes on the Earth, and the nuclear reactors, fusion reactors, that becomes a reality. So that is one thing that scientists are eyeing on. Apart from that, there are rare earth elements, and wherever there are wherever there are rare earth elements, China goes there. So like Africa, China goes there, and they have interest in the South China Sea. They also have lunar interest because of the rare earth elements. Very, very important for the electronic industry. Moon is also having substantial reserves of titanium and iron, and claiming these resources and extracting them and appropriating them, bringing back on Earth, is also one of the reasons why there's a lunar rush. And satellite servicing. If we are sending some missions to Mars or Venus, or deep exploration missions, interstellar missions, Moon is going to act as a permanent outpost for refueling, for servicing, for relay missions. So it is very important. Also for commercial space tourism, that is going to open up, already has started, very limited scale, but it will open up for general people, obviously in that economic bracket. But commercial space tourism, if this becomes reality, then economic benefit is going to come to the countries. So the third reason I'm spelling out is economic. However, the NASA has, in its many of the research papers, said that there's going to be crowding in the South Pole, because South Pole has craters, and the space that are left from the craters, there you can actually place your lunar outpost that is limited, and whosoever goes there first and claim the area will have the first mover advantage. So there's a rush, and NASA has set that the year 2030 to have it. 2030, and almost the same time China is also set, because whosoever goes there first or will have an obvious advantage to have a better positioning in the South Pole. The fourth reason I am giving you is geostrategic. As I told you that United States is leading the Artemis Accord, the Artemis coalition, and 61 members, I last checked, I think it was 61 nations have become signatory to the accord. Although they say it's grounded in the 1967 Outer Space Treaty, but they obviously have economic and geostrategic interest in bringing a treaty outside of UN led by US. So it's not a convention that everybody is signing. It's a bilateral agreement, and US is getting into every country, agreement with every country on a bilateral basis. So bilaterally, US is getting into agreement. It's not a convention that everybody is signing. ILRS, it is International Lunar Research Station. This ILRS block is led by China and Russia, and there are roughly 17 partners in this block as well, and they both are competing to get there by 2030. So it's the win of a block. It's not just economic or scientific anymore, it's geostrategic, and on some scale it is also civilizational. So whosoever gets there first will have the dominance in the technology, will have dominance in the future energy, will have dominance in geostrategy. And China is accelerating it. You know, China in 2019 had the Chang mission. Chang series is the Chinese series for the lunar mission. Chang 4 was the first ever far side soft landing. The landing done so far was on the near side, the side that faces us. The far side landing, as I told you, that radio communication cannot be done from the far side because of the depth of the moon. The diameter is around 3,500 kilometers, and radio waves cannot penetrate through it. It cannot. So you cannot communicate from the ground stations directly. So they had a satellite for it. On the far side of the moon, the other side you cannot communicate. So from that side you communicate with a satellite. And from the satellite, the communication with the ground station on Earth, there was a relay satellite. But they did it, all of that, but they had a landing in 2019 on the far side. In 2020, Chang 5 returns the near side lunar sample. And 2024, Chang 6 returns the sample from the far side. And in 2030, they are targeting a lunar landing on the surface of the moon and the long-term stay. So their graph is increasing with regard to the lunar exploration and lunar mission, and they want to be the first to get into lunar governance. So there is a geostrategic reason why they want to go there, and there's a lunar rush. The fifth reason I'm giving you is not much talked about in the public discussion, but it's very relevant. After so many satellites in the near Earth orbit and in the medium Earth orbit and the geostationary orbits, there are so many missions, there are so many telescopes, space exploration missions and satellites. There are a lot of radio signals coming towards the Earth, and ground stations signaling it towards the satellite, and that is creating what is now called as radio frequency interference. So from the surface of the Earth towards the near side of the moon, there is a lot of radio frequency interference. The far side of the moon, and forgive me for this, for interchanging it, the far side of the moon is radio shadow zone. There is no radio wave disturbance from the surface of the Earth there. And this zone is now scientifically very important because the radio telescopes on the far side can study the outer space without radio frequency interference. So there are plans, and NASA has two heavyweight plans for the far side of the moon. China also has it. China has in fact landed on the far side of the moon and brought the sample from the far side of the moon. So they are going to appropriate the far side of the moon as well very soon. And from the perspective of astronomy and exploration and study of the deeper part of the universe, This is going to be very, very significant. And so first thing is physical shielding, approximately 3,500 kilometer of diameter that blocks it, that blocks radio waves. So there are no radio waves there. So that's good. That's a good thing. Secondly, you know, ionosphere of the Earth doesn't allow the harmful radiations. So it doesn't allow frequency after a particular range, after a particular threshold to reach to the surface of the Earth, because that is harmful to us. And you understand the gamma rays and the X-rays, of course, they are absorbed, the ultraviolet, they're also absorbed. But high frequency radio waves, they're also attenuated from the atmosphere and they do not reach to the surface of the Earth appropriately because of the ionosphere. The moon doesn't have the ionosphere. The moon has no atmosphere at all. So from that perspective as well, some of the radio waves that do not manage the wavelength, which are less than 10 meters, frequency higher than 30 megahertz, they do not manage to reach the surface of the Earth appropriately. But they are important. They are important to study the space that was created after the Big Bang. So that will be available on the far side of the moon. So from this astronomical perspective, from the perspective of future research, the far side of the moon is important. So there are going to be more missions on the far side of the moon in the future. There are two things that you must also bear in mind from the perspective of your prelims exam. NASA has planned LCRT, Lunar Crater Radio Telescope. It's a mammoth-sized telescope, 1 kilometer in diameter. And there will be robotic fixation of that in a crater that is around 4 to 5 kilometer in diameter. So it's a huge, huge telescope that's going to they are planning to place on the far side of the moon. And another is far view array. There's a dipole style of telescope, and this will be spread over 200 kilometer square area on the far side of the moon. And you know what, they'll be made in situ, manufactured in situ from the lunar regolith metals by 2030s. This is hugely aspirational, but they're planning to do both of them very, very soon, and to study the events after Big Bang in the what they call as cosmic dark ages, ages before the first stars were formed. And to study the radiations, they require the absence of interferences from the other radiations which are there around the Earth and also in the low Earth orbits. So we have to go to the far side of the moon for this. These are the reasons I'm telling you that were not previously identified as the cause or the drivers to go to the moon. That is why there's a increased resurgence in the interest for the lunar missions. So this time around, the lunar mission is not going to be like Apollo mission. We are going to have a permanent base stations with permanent experiment laboratories, with permanent on-off, to and fro supplies going on to the moon, and with aspiration to go beyond the moon to the Mars, and then beyond the Mars to the Venus, and then beyond the Venus to the interstellar spaces. That is why it is going to be different, and that is why NASA has cut down one of the leg of Artemis. You know, they were planning in stages first. They are planning Artemis 1, I hope you understand, was the testing of the aircrafts and the launch vehicles. Then Artemis 2, they have done it, flyby. Artemis 3 was landing. Artemis 4 was a outpost orbiting around the moon. Then Artemis 5 was a ground station. They have cut off that leg of outpost. They do not want an orbiter outpost around the moon. They want a permanent station. So the lunar gateway, as they called it, that has been slashed. This whole, the resources, the money, everything planned for this will be going towards the ground operation. So they are interested in a permanent ground post on the moon. So on the moon, you know, launching of the satellites can be done from there in the future. All the satellites are launched from where? From here on the Earth, and Earth gravity is more fuel. In situ, when you have building up of satellites in the future, you can launch the satellites from the moon. You can launch the space stations, the space programs from the moon. That has never been done. So it is going to throw new opportunities for us. That is why the interest in the moon is increasing. More money assigned. So far, $107 billion right from 2009 till now. But in the next few years, $20 billion more is being planned by NASA. So the interest is huge, and you can see from the numbers. Interest because of science and geopolitics and economics, it's all merging. And the parallel effort of both the US and Chinese blocs reflect a shared recognition. Whosoever builds durable infrastructure first will write the rules for the lunar surface for the century ahead. That's why the moon is not just an artifact from the past. Moon is going to be a launch vehicle, not just for scientific studies, but also for geostrategy and overall governance on the moon, and by extension governance on the earth. And that sums it up. That's why there's a huge amount of interest to reach on the moon.